analyst utilizes the ANOVA test results in an F-test to generate additional data that aligns with the proposed regression models. The analysis of variance is employed if there is no access to statistical software, resulting in computing ANOVA by hand. T-test is an inferential statistic used to determine if there is a significant difference between the means of two groups and how they are related. Hello everyone, I am Purnima, faculty in the Department of Commerce and Management, Vidhyaashram First Grade College, Temple of Excellence, MYSURU. I welcome you all to this session. In this session 4 of Unit 5, we will be having a look at we'll be having more information on ANOVA. So, the formula for ANOVA equals F equals MST divided by MSE. So, whatever the value you are getting after the ANOVA test, that we call it as the F value, or it is also called as the ANOVA coefficient. Now, in this formula, we have in the numerator MST. MST means mean of squares due to treatment. MSE means mean of squares due to error. Now, the ANOVA test is the initial step in analyzing factors that affect a given data. So, we all know that the ANOVA test is used when we have multivariate data or we have lot of data relating to a particular subject. So, this ANOVA test will help us to know what are the factors that affect that particular given data set. Once the test is finished, an analyst performs additional testing on the methodical factors that measurably contribute to the data set's inconsistency. So, what are those things which affect the data set and what are those factors which do not affect the data set that we can measure? The analyst utilizes the ANOVA test results in an F-test to generate additional data that aligns with the proposed regression models. So, whenever this ANOVA test is done, it will give us the results in the F-test. So, with the help of the F-test, we will be able to do the regression analysis on that particular data set. Then, if no real difference exists between the tested groups, which is called the null hypothesis, the result of the ANOVA's F ratio statistic will be close to 1. So, when we are having this ANOVA test, then if there is no difference between the tested group, which is called as the null hypothesis, then the result of the F ratio will be always close to 1. The distribution of all possible values of F statistics is the F distribution. So, this is what do we mean by F distribution? F distribution is a group of distribution functions with two characteristics numbers called the numerator degrees of freedom and the denominator degrees of freedom. Then, a researcher might, for example, test students from multiple colleges to see if students from one of the colleges consistently outperform the students from the other colleges. So, in a business application, an R&D researcher might test two different processes of creating a product to see if one process is better than the other in terms of cost efficiency. So, here we have an example here. So, in this example, we can see that with the help of the ANOVA test, we will be able to know why when we have data relating to students of multiple colleges, then we will be able to analyze how one college students outperform the performance of the other college students. So, in the same way, in case of a business application, that is the research and development. So, we have the R&D section. So, this R&D researcher, they might test two different processes of creating a product. So, there are various methods of creating a product. So, which is the best method? Which is the most cost efficient method to produce the product, so that we can find out with the help of the ANOVA test. Then, the type of ANOVA test used depends on a number of factors. It is applied when data needs to be experimental. Then, analysis of variance is employed if there is no access to statistical software relating in computing ANOVA by hand. So, the type of ANOVA test, what is the type of ANOVA test we need to use when there are a lot of data relating to a particular study? Then that will be depending on a number of factors. So, it will be applied when data needs to be experimental. So, we can make use of the ANOVA test when the data is experimental. The analysis of variance is employed if there is no access to statistical software resulting in computing ANOVA by hand. So, it is simple to use and best suited for small samples. With many experimental designs, the sample size have to be same for the various factor level combinations. So, this kind of ANOVA, it is very simple and best suited for small samples. So, with many experimental designs, the sample size have to be same for the various factor level combinations. Then, ANOVA is helpful for testing 3 or more variables. It is similar to multiple two-sample t-test. However, it results in fewer type 1 errors and is appropriate for a range of issues. ANOVA group differences by comparing the means of each group and includes spreading out the various into diverse sources. It is employed with subjects, test groups, between groups and within the groups. Now, this ANOVA, it is helpful for testing 3 or more variables. So, when there are more than 2 or 3 variables, this ANOVA test will be of multiple uses. So, it is similar to the two-sample t-test. So, the two-sample t-test, so it will be where we can use this ANOVA. Then, ANOVA groups differences by comparing the means of each group and including spreading out the various into diverse sources. So, this ANOVA, it will help us in finding out the group differences by comparing the means of each group and also spreading out the variance into diverse groups. So, it is employed with subjects, test groups, between groups and within the groups. So, first thing is they'll calculate the mean of the given data set. Then for each set of data, they just find out the mean and then they find the mean of all the data together and then they will also find the data within the group. Next one is, what is a t-test? A t-test is an inferential statistic used to determine if there is a significant difference between the means of two groups and how they are related. So, as I said earlier, in the ANOVA test, we have a mean. We have to calculate the mean of a given set of data. Suppose there are 2 sets of data given, then they have to find the mean of each set of data. So, a t-test is an inferential statistic used to determine if there is a significant difference between the means of 2 groups and how they are related. So, this t-test will help us to know what is the significant difference between the mean of the 2 groups and also how they are related to each other. They are used when the data sets follow a normal distribution and have unknown variances, like the data set recorded from flipping a coin 100 times. So, this kind of a data t-test will be used in case of normal distribution which have unknown variances. So, unknown variances means we will not know what is the outcome of each of the event. So, just like it is a simple thing like flipping a coin. So, when you flip a coin, we will not know whether it is a head or a tail. So, the outcome is unknown until the event happens. So, when you record all such events, whatever is unknown or we cannot predict, so that for that data, we can make use of this t-test. So, you can see here in this diagram, a statistical test used to compare the means of 2 groups of data. So, 2 groups are there here. So, we will be able to compare the means of the 2 groups of data. So, the t-test is a test used for hypothesis testing in statistics and uses the t-statistic and the t-distribution values and the degrees of freedom to determine statistical significance. So, it is a test used for hypothesis testing in statistics, and it uses the t-test, t-distribution values, degrees of freedom to determine the statistical significance. Then, next one is a t-test is an inferential statistic used to determine if there is a statistically significant difference between the means of two variables. So, what is the statistical difference between the means of two variables? That we will be able to know with the help of the t-test. Secondly, it is a test used for hypothesis testing in statistics. So, for the hypothesis testing, we can make use of the t-test. Next one is calculating a t-test requires three fundamental data values, including the difference between the mean values from each data set, the standard deviation of each group, and the number of data values. So, for the t-test, if you have to conduct the t-test, we need to know what are the different. So, it includes the difference between the mean values of each data set, the standard deviation of each group, and the number of the data values. The t-test can be dependent or independent. Then, next one is a t-test compares the average values of two data sets and determines if they come from the same population. So, in the above examples, samples of students from class A and sample of students from class B would not likely to have the same mean and the same standard deviation. So, with the help of the t-test, we will be able to find out if the data is coming from the same population or not. For example, if you are having a data relating to the scores of students of class A and class B, then the mean score of class A and the standard deviation of class A will be different from the mean score of class B and also the standard deviation of class B. Similarly, samples taken from the placebo-fed control group and those taken from the drug prescribed group should have a slightly different mean and standard deviation. Mathematically, the t-test takes samples from each of the two tests and establishes the problem statement. It assumes that a null hypothesis that the two means are equal. So, the t-test will take a sample from each of the two sets of data and establishes the problem statement. So, it assumes a null hypothesis that the two means are equal. So, using the formulas, values are calculated and compared against the standard values. The assumed null hypothesis is accepted or rejected. If the null hypothesis qualifies to be rejected, it is indicated that the data readings are strong and probably not due to chance. So, with the help of these formulas, values are calculated and compared against the standard values, and if the null hypothesis is rejected, then we can say that the data readings are very strong and it is not due to probability. Next, the t-test is one of the many tests used for this purpose. Statisticians use additional t-tests other than the t-test to examine more variables and larger sample size. For a large sample size, the statisticians use a z-test. Other test options are the chi-square test and the f-test. So, there are the various types of tests. So, if the data is small, you can go in for the t-test. But if there are large number of data, then it will be wise to use the z-test, the chi-square test or the f-test. Next, consider that a drug manufacturer tests a new medicine. Following standard procedure, the drug is given to one group of patients and a placebo to another group called the control group. The placebo is a substance with no therapeutic value and serves as a benchmark to measure how the other group administered the actual drug response. So in this example, we have the example of a drug manufacturer where there are two sets of patients here. So for the one set, they are just giving a placebo fed group, that is any drug which does not have any therapeutic value. And for the other group, they are administering the drug which has therapeutic value. So they will be able to find out the effect of the drug on the second group of people. So they will be able to know what will be the reaction in the body of such patients. So this will be, we can do with the help of the t-test. Then after the drug trial, the members of the placebo-fed control group reported an increase in the average life expectancy of 3 years, while the members of the group who are prescribed the new drug reported an average life expectancy of 4 years. So we can see that result easily here. So the placebo-fed group, they had a life expectancy of extra 3 years, whereas those fed with the new drug, they had a life expectancy of 4 years, only just 1 year extra than that other set of data. Then initial observation indicates that the drug is working. However, it is also possible that the observation may be due to chance. A t-test can be used to determine if the results are correct and applicable to the entire population. So, with the help of initial observation, we can see that the drug is working. But then with the help of a t-test, we will be able to determine whether the results are correct or not, or whether this entire result, whatever we have got from this research, whether it can be applied for the entire population. Then 4 assumptions are made while using a t-test. The data collected must follow a continuous or ordinal scale, such as the scores for an IQ test. The data is collected from a randomly selected portion of the total population. The data will result in the normal distribution of a bell-shaped curve, and equal or homogeneous variances exist when the standard variations are equal. So there are 4 assumptions made while making a t-test. So what are the 4 assumptions here? The data collected must follow a continuous or ordinal scale, such as the scores for a IQ test. Then the data is collected from a randomly selected portion of the total population. Then the data will have a normal bell-shaped curve, and then equal or homogeneous variance exists when the standard variations are equal. So we have to have these assumptions. Then calculating a t-test requires 3 fundamental data values. They include the difference between the mean values from each data set, or the mean difference, then the standard deviation of each group, and the number of data values of each group. So for the t-test, we need 3 types of data. So what is this? What is the 3 fundamental data values? The difference between the mean values of each set. So mean 1, mean 2, mean 3, mean 4. So what is the difference between each of the values? That we have to know. Second one is the standard deviation of each group. Standard deviation 1, standard deviation 2, standard deviation 3, standard deviation 4, and the number of data values. So we need the number of data values of each group. Then the comparison helps to determine the effect of chance on the difference and whether the difference is outside the chance range. The t-test questions whether the difference between the groups represents a true difference in the study or merely a random difference. So this t-test, with the help of t-test, we will be able to analyze whether the data, whether 2 set of data which we have received, whether it is from the same population. This is the first thing. Second thing is, it will help us to determine the effect of chance on the difference and whether the difference is outside the chance range. So if there is a difference between the 2 data sets, then it will also help us to analyze whether the difference is because of chance or not. So it questions whether the difference between the 2 groups represents a true difference in study or merely a random difference. It produces two values as its output, the t-value and degrees of freedom. The t-value or the t-score is a ratio of difference between the mean of the two sample sets and the variation that exists within the sample test. So, with the help of the t-test, we will be able to get two values as its output. One is the t-value, the second one is the degrees of freedom. So, this t-value or the t-score means it is the ratio of difference between the mean of the two sample sets. So, it is the t-value is nothing but the ratio of the difference between the mean values of two sets of data and the variation that exists within the data sample sets. Then the numerator value is the difference between the mean of the two sample set. The denominator is the variation that exists within the sample set, and it is the measurement of the dispersion of variability. So, in the numerator, we have the difference between the mean of the two sample set, that is mean 1, mean 2, difference. Then the denominator we have is the variation that exists within the sample set, and it is the measurement of the dispersion of variability. So, what is the variability between the two sample sets? So, that will get in the denominator. The calculated t-value is then compared against a value obtained from a critical value table called the t-distribution table. Higher values of t-score indicate a large difference exists between the two sample sets. The smaller the t-sample, the more similarity that exists between the two sample sets. So, the t-value will be compared with the help of a t-distribution table, and then the t-score indicates that a large difference exists between the two sample sets. So, if there is a lot of difference between the two sample sets, so it means that the high value of the t-score means there is lot of difference between the sample set, and the low score value means there is a lot of similarity between the two sample sets. Then a larger t-score or t-value indicates that the groups are different, while the smaller t-score indicates that the groups are similar. So, with the help of the t-test, we will be able to know whether the groups are similar or whether the groups are different. So, the degree of freedom refers to the values in the study that has the freedom to vary and are essential for assessing the importance and validity of the null hypothesis. So, we will be able to assess the importance and validity of the null hypothesis. The computation of these values usually depends upon the number of data records available in the sample set. With this, we come to the end of this session. Hope you have all followed it. Thank you.